students. And then we have 8 minutes of Q&A. So when total is 18 minutes, please. And then you need to sit down, and then we rotate to the second speakers. Okay, so today's first speaker is Zhou Haochen, and he's going to share with us the fusion of drone and the satellite data for precision agriculture monitoring. Yes, please.
Hi, I'm Zhou Haochen, and today I like to talk about fusion of drone and satellite data. Okay, look at this picture. This is a satellite image from Formosa 5. And in past research, we can classify in many classify, such as vegetation and water or soil. But we can do within classify, such as dense vegetation or sparse vegetation. So if we add drone image data, we can do this. The data they use. First, they use Landsat 8. This is from NASA. And the second, they use DJI drone. It's like that. With 4K resolution RGB camera. And next is the flow chart. First, we have two input. Both input need pre-processing. And segment every big picture to sub pictures, and then process every sub picture. So the next is classify image. They classify image into vegetation class and water class or soil class. And then they extract the vegetation class by compare the image with drone. And then they discussion the sparse and dense area and the output, and we can have the output classify image. So let's move on to classify image. First, they do the minimum noise fraction. It can reduce the dimension because the Landsat 8 have 11 bands, and they use in this research they use seven band. And the next is pixel purity index algorithm. This is to identify the most spectral pure and number, which can choose the best band to classify the vegetation and the others. And next is it compare the data with the band they choose, and they can classify several classes. So this is an example. First, we have RGB image, which is full color image, and the second is false color image. And we can have this classified image. Every color present different classes. Okay. Then the vegetation expression, they make a mask to make this classified image to this. The white is the vegetation area, and the black is the other classes. So the next is distinguish spare and dense. First, they choose the ground truth from the drone image. And this is the image taken from drone, and this is dense area, and this is sparse area. So they choose, I think it's by manually. Okay, the next, they choose the best band to classify these two classes, because these two classes cannot simply classify by only that 7 bands. So they create a separability index. The equation is like this. The result of the separability index, we can see here are 5 bands. Let's see this. Here shows the 2.5 separability. So because it is the greatest, so it shows that it have a separability. If it has the greatest separability. Okay, the next is once we separate. Once we choose the best band to separate these classes, so we have to do a thresholding, and this is the automatic thresholding. It's called auto. And if we see the histogram of band 6, which we choose, we can see here's a very, so that's the line we have to separate. Okay, the result is the green is the dense vegetation, and the red is the sparse vegetation, and the black is the other classes. So they compare to only drone image and calculate by calculating manually, and we can see, if we see these two data, the satellite will classify most as sparse vegetation is bigger. And if we see these two, we can find the vegetation area, and the other area is precision. So they think this is a good method to classify two vegetation classes, and it opens up a prospect for within classification. And okay, this is the reference. Thank you.
Any questions or comments? First thing I would like to comment is, Zhou is very good to put the page number. Remember last time you missed the page number, now you put the page number, it's good. Any comments or questions? Yes, please.
First, I just want to say that I like your presentation. It's just that at the start, I didn't understand very well the explanation of the context. I mean, I think for me, you went too fast in the subject, and I didn't understand very well the goal of.
Sorry, I don't understand your question.
Oh, well, what is? Didn't understand the main goal of your presentation.
Goal, okay.
Yeah, thank you.
Okay, their main goal is to distinguish sparse and dense area. Because this is a within classification, which is not done before in the past research. So they think they add the drone data can improve the classification to do the within classification.
Yeah, and the goal of distinguishing sparse and density is just to identify vegetation and adapt inputs in fields, for example, or what is the goal for this? I mean, it's a good thing, but after what do you do with this? I mean, what's the purpose behind this?
They just want to once we have this classification, maybe we can do more like classify every crops or vegetable like this. Okay.
Okay.
So this is a start.
Okay. Thank you.
Okay, thank you. And you have comment or questions?
I just wanted to ask, could you please explain the histogram?
Histogram.
Yeah, I didn't really get it during the presentation.
Sorry, can you pardon?
No, I just wanted to know what the histogram is about.
Oh, this histogram is about the in band 6, which is shortwave infrared. The band is chosen by this algorithm. So they choose this band.
Okay, thank you. I get it now.
Okay, thank you.
Any more? I have some comment for you. Actually, I don't know this. May I see the first page of the slide?
First page.
So this published in 2016, and you know in which journal? Seems from this guy's from India.
Yes.
India's last name. Maybe Middle East. Actually, when you get the image from, the spectral image from the satellite,
yes,
you can do NDVI, anything. You don't need to do the thing they did. And I little bit doubt that the fusion, because you use they use the fusion, means the combination of the satellite and also drone. And I'm very doubt for this case, because you have the good pictures, you can examine by human beings' eyes, so you can get the results. But
okay.
But I think it's only for research. For the real case, I don't think it's workable. And also either drone or either satellite, either one, could do the same job as they did. So before the drone, say 10 years ago, there's no drone, still satellite. And then you can do the same thing. Different vegetables, different crops, and you can use the image with some vegetation index. NDVI is one of them. It's not the only one. There are actually many vegetation indices, and you can use it to distinguish the different crops or different object. For example, there's a river and there's the farm, and the land, only the land, and there's a house and so on. So I did a thought about the workable, application of this results, and also use both the drone and satellite May not be the smarter way to do it, because the drum, once you have a drum, you can do more flexible way and use the satellite. You got to wait and you need to pay money, because the satellite you want to get the image, then there's a charge. It's not free at all. So this is my comment.
Okay.
Any other comments or questions? How many minutes do we still left? 3 minutes left. One more comments or question? Go to your definition, SI.
Definition of SI.
Yes. Okay. Just want to tell you that the SI is a good index to determine which parameters or which variable, or which the way of your setting. You say there are many ways of setting, and the bigger SI is the great ability for differentiation of the two groups. But that's only for two groups.
Okay.
Okay. If there's no more questions or comments, then we thank Mr. Zhou Hao Chen for the excellent presentation. Thank you.
Thank you.
And our second speaker is the Zhe Weilin. Okay, please go forward to the podium. Okay, and your PowerPoint.
Okay. Good morning, Professor Chen and Professor Yan. I'm Lin Zhewei, and today I'm talking about evaluation of NIRS, non-destructive test to evaluate the quality traits of purple passion fruit. Here's the author. So let's talk about what is the passion fruit. People things is sweet, and some things is sour, and some things is juicy. So how can we know that what is this kind of fruit tastes like? Originally, we taste the juice of it, and we can know it is sweet, sour, or juicy. But it is not the proper way. We can know that before we drink it. So we got to use a non-destructive method to test that, to know the quality of the fruit. So here comes the material and the method. First, we plant the fruit on the Thailand mountain, and on the altitude of 800 to 1200 meters high. Then we use the subtropical method as a non-destructive test, as got an estimated value. Then chemical and physics analyze as a real value to find a relationship between them. Then we can got a model from both of them. So let's introduce some about the subtropical measurement. Here's the machine we used, the same as we had in our laboratory. It is the fourth NIR system 6500. Then we got data from the passion fruit. Each passion fruit have 3 data, so it turns 120 degree each fruit, and then take the average of them. Then we talk about the chemical and the physics analyze. First is the total soluble solids. It has a high relation with sweet. Here's the machine we have, and then the tolerable acidity. It means the sour. So first we use 1 and 10 times of water, and then put the NaOH solution into the solution. Then till the pH value reached 8.2, so we can got the tolerable acidity for that. Then the last thing is the pulp content. That means the juice. So we take the original fruit, the weight, then subtract the ring of the fruit, then we got the pulp content. So here comes the result. This is the subtropical measurement we got from the NIR. And you can see that this is the average of data from 800 to 1200 meters high. So we can simply see that the 800 meters high fruit has the highest absorbance. Here's the chart we have. First, we can see the TSS value is the highest on the 1000 meters, and the sours TA 1200 is the sourest, and the 800 has the most pulp content. That means it is the most juiciest. And we can see this is a coefficient of variation. So we know that the sour influenced by the climate a lot. So this is the model we have from the spectrum and the real actual value. Also, we can see the gray point is original that correlation with the NIR with the actual value. So it is quite similar, but it is not the best. But after we done some method and some calculate, we can switch a point to a more similar. So we can see that the actual value is 158, and the NIR predicted is 156, and for the total soluble solids. So let's come to the treatable acidity. We can see the same thing. The actual, the black point, gray point is the convolution of actual value and the NIR data. So it is close, but not the best. But to the predictions we have, we need this closer than only do the convolution. And let's come to the pulp content. The original is not that similar, but the model we predict with which is more closer. So here's the conclusion. We can see from the charts the high pop contents has the highest absorption, and the NIR tropic of the elevation passion fruit quality is well proved. That's all my presentation. Thank you so much.
He welcomes comments or questions. Any of you? Yes, please.
Yeah, I had just a quick question. It's about the experiment. You said that the passion fruit were took from different levels, from depending on the sea. But yeah, so in Thailand mountains, it's roughly the same area, or because
The same area, but the different altitude.
Okay, so it's quite on the same mountain, right?
Pardon?
It's quite on the same mountain.
Yeah.
Yeah, okay.
Any more? How you measure the pop content? By weight or something?
No, by
ratio,
weight.
The ratio of weight?
Yes. So this is the original we got from the fruit, and we measure the weight of that. Then we remove the meat inside the fruit. Then we measure the weight. So we subtract both of them.
Okay. Just comment. Don't say that's meat. Fresh.
Oh, okay.
Fresh.
Okay.
Meat is some from an animal, so you say fresh. 果肉叫 fresh.
Okay. Fresh.
动物的肉叫 meat. Okay. Any more comments? Yes.
I like the presentation a lot. And can I ask what is Thailand mountain? The previous slide. Yeah.
Thailand mountain. You say this?
Yeah.
The mountain in Thailand. Yeah, that's my mistake. Yeah.
It's okay. It's THAI.
Oh, I'm sorry. Sorry for that.
I just had another quick question. It's about the passion fruit. Was it? Did you make sure that it was the same variety of passion fruits?
Pardon?
The same variety of passion fruit, maybe because sometimes you can have different type of passion fruits. So it was, you made sure that it was the same passion fruit?
Yeah, the same.
Height is the only reason that infuse the passion fruit, or maybe another reason to infuse it.
Pardon?
I mean, the height of the mountain is the only reason or not. Maybe some of reason can influence the passion fruit.
I see.
How do you show the height is the only reason?
Yes, as we can see from this spectrum, we can see that the absorption of passion fruit from 800 meters has the best absorption, and then the 1200 has the least absorption. So we done the correlation with the absorption and the actual value, so we can predict the model for that. So we can see that the value from them from the climate influence a lot only in the tutorial acid, means the sours varies a lot because of the altitude. Yeah.
So that's okay. Any more?
I like your presentation. It's easy to understand. Can you jump to the method?
Which
The next
okay.
and next.
This one?
This chemical measurement, the three method, is there? Is it possible to combine together to a number or how do you use this data? Is it possible combine together by an equation or combine
with,
together?
No, combine these three types of data together.
Yes.
No.
So it is.
We find a relationship between the NIR data and these three types of data, the value of that.
So this is so that is separate. Separate.
Yeah. Separate.
So you compare separate.
Yeah. Yes.
Okay. Thank you.
You're welcome.
One comment. One comment of the pH, P must be lowercase, 小写, and H is capital case. Okay, usually. And I have a question about why 8.2, not 7. You use the NaOH to neutralize the solution. Why is 8.2, not 7?
The author didn't say that. Why they reached the 8.2, but I guess that some passion fruit is not that sour, so probably the pH starts from 7 or more than 7, I guess.
It doesn't make sense to me. Better to go deeply to see why they set it 8.2 and make it a explanation to the audience. And okay. Excuse me, Eugene, you have some comments or questions? You don't want to say something? You're familiar with these materials. Okay, because while you are thinking, I have another question. I go to page 9 or page 10. Okay. Yeah, either way. Okay, previous one, 10, okay. You show us the 3 plots like this, but it did not show how the model was built. So for example, use MLR, and PSR, some kind of regression model, and what's the correlation coefficient, and what's the error, standard error. It's most important to show that instead of you say, okay, see this one, and 11 and 10.5 is more matched together, and A and 99 is more far off. And this comparison, you spend probably 1 or more than 1 minute on 3 plots to show the green one and the red one. I think it's not the appropriate way to tell us, is this good enough? Instead of showing that, you need to show us what's the R, the correlation coefficient, what kind of method used, MLR or MPSR. These two are the most common regression model were used in the near infrared area, and also the error, the standard error of how much. And from that, we can judge how the model is good or not. Okay. So this is my suggestion. Okay. So instead of saying that, you need to show the model they use. Do they use a model? What kind of model they use in the paper? Did I say?
Yeah. Yes, but yeah, they did say, but needs lots of calculate. So I didn't show that.
No. You only say what kind of model and also the R and also standard error. That's all. Okay. Oh, all right. Time's up. The first page. Okay, here's THAILAND, Thailand. So that's correct. And something I'd like to say, this is not the complete way to cite a reference because we don't know which year. We only know the authors and of course the title of this. So it's better to give us the year and also where this article was published. And so in the EAEF or in the SAB or in some other journal, and everybody knows the format of the reference. So you need the content of the authors, year, title, and also the journal name of the journal. So you may have a better idea what's going on. Okay, and so maybe just 20 years publication maybe, and I doubt it, but I think it's better to give more information to your audience. Okay, all right. So this is the end of the second speaker. So thank you very much.
Thank you.
And the following three speakers will be chaired by Professor Yan, please.
Yeah, so let's move to the third presenters. Yi Jingwu, yeah, please.
Hello, everyone. My name is Yi Jingwu, and I like to talk the non-invasive characterization of chick embryo body and cortical movements using near infrared light. And is my contents have okay, and the content is during early and embryonic development, the restricts early embryonic movement may cause wrong position and reduce heart rate and blood flow, and the natrium delivery. So it is important to monitor the movement of the embryo during the incubation and to quantify this physiological activity. And this is this picture is the researchers the device. Okay. And these two devices recent have to use to measure the envious in embryos, the heart and his movement, and the first one is it was invite for people who want to monitor mirrored eggs, but it is high possibility of including body movement in the heart rate measurement. And the second one is too expensive, and the operation environment is strict, so it's not feasible in daily use. So because body movement frequency and heart rate are important parameters of health status, so this research establish a standard method to investigate non-invasive movement pattern of embryonic body and heart during the incubation period. Use near infrared light, and they choose 100 light-born logic type egg and choose 51 eggs for hunting by consideration of large diameter, medium diameter, mass, and shell color. The purpose of this egg sorting is to minimize experimental variation among egg samples. Okay, and they use the NIR sensor called vital scope to measure the transmitted light signal of all egg from combustion day 6 to 19. Eggs will take out of the incubator every 20 hours to acquire a 9-second transmission signal of each egg, and it consists of 6 LEDs to emit light at 870 nanometer, and a photodiode is receives the light pass through the egg, and the voltage signal obtained by the NIR sensor was transformed into the frequency domain. Use the faster Fourier transform. These figures show original time domain chicken embryo activity signal, and the small fluctuation is mean the heartbeat. The big fluctuation is mean the body movement. And the right picture is showing two frequency component where the lower frequency is mean body activity. The higher frequency is mean cardiac activity. So, and this picture is at incubation of embryos at day 7. The first body movement begin at day 5, and the residual eminent contraction begin at day 6. And in day 6 to 8, body movement will characterized by a periodic signal with frequency between 0.3 to 0.8 Hz. The mean and the later stage of incubation by irregular movement in a lower frequency. Okay. This picture showing in day 7 to 8 has the first peak, but it will reduce because the embryo's hand start become heavier. The prediac movement changes to an irregular movement as the embryo transition to the growth phase from the formation phase. The state of the motion on day 9 to day 13 become random and unintegrated. The heart rate of the embryo in the last half of incubation varies little, dropping slightly from day 13 and rising again from day 16. Okay, the changes may be due to heart size and structure of cardiac muscle and embryonic developmental stage response to the external incubation environmental. The heart rate increased rapidly with the change of incubation time, but the rate of the slower around the day 10, peaking at the day 14 to 15, and then subsiding. However, as the embryo begins to grow, as the incubation time increases, the heart becomes less visible because the apprehension of his sink or failures, and they will affect the transmission line intensity and the end of the incubation. So in this paper, cardiac signal change represents the relative growth and maturity of the embryo and its heart. The conclusion is this research implementation of the new technology and use the non-destructive monitoring and use near-infrared sensor combined with signal processing at the same time. And this technology is more powerful than the technology currently in use because it can not only separate body activity from heartbeat, but also can quantify both of the movement in terms of frequency and state. Okay, it is my presentation. Thank you.
Thank you. So any questions or comments? Okay. Yes.
Thank you for your presentation. I think you've done a very good job. I want to suggest you make your words more larger. Yeah, that's it. Thank you.
Thank you.
what will be the daily use of this paper? Like, what is its purpose on our daily life?
Its purpose is to make a new technology to make sure the chicken embryos in early incubation time to check their health and its health and heart. Because these two device cannot separate heart rate and body movement. So this research is make a new technology to do it. Okay.
Yeah, please.
And this technology can be applied for other type of birds, like parrots, or maybe because some birds can be very protected or endangered. So maybe this technology can be used for other birds to be aware of if they grow well or something. Can this technology be used for other birds?
Yes.
Yeah. Thank you.
Nina, you, please.
Thank you for your presentation. Could I ask what is the function that machine do? This slide show the top one.
The top one. This one.
Yeah.
Is major used to make to check the 那个 parents 就是 someone who 就是 who want to know parents' heart and his body movement in the when he was an egg. Yeah.
Okay, so because of time, I also want to give comments on this page. So because the page, you can feel that a lot of questions related to this page, right? Because this page is talking about the purpose of the paper. So instead of, I think it's good, but you may consider to put more words on this page and then give more information for the audience. Yeah, if you are the jobs, you can have only one figure, but for normal people, you probably consider to put more words, then people will understand more. Okay, yeah. That's the technique to prepare your presentation. Okay, let's thank Ms. Wu. Yeah, thank you. Yeah, the first paper. 韦汉洲是谁啊？韦汉洲是吧 ？Yeah, it's you.
Okay. So today I will be talking about 3D printing in artificial meat. So this is not really an experiment. This is not really an experiment, but more of a introductory to the process of how artificial meat is created. And there's not much information out there, so because it's a new technology, so a lot of information I had to research on my own. And why there's even the process of artificial meat is because of like drawbacks in conventional meat where the meat is used from actual animals. And there are a few reasons to why it's a problem in our world today. And number one is because it is a use of farm animals. So they raise the animals in the farms and their only purpose is to be used as food, and they're killed in like really inhumane ways, and that's how they're introduced into the market. And there's also a nutritional related disease, which is like diseases contracted through the raising and the breeding of the animals, like E. coli and a lot of the other diseases which you will get from eating it. And the foodborne pathogens are the diseases that go into the meat when you consume it, so when you eat it. And there's a lot of environmental pollution. Today, just in the US, 83% of the land is used to raise livestock. So basically, it is used to raise animals for the purpose of being consumed. And the type of synthetic meat or artificial meat I'll be talking about is the in vitro meat. It's also known as cultured meat, test tube meat. It's grown in the lab. So you don't actually harm an animal. It is grown through the lab process. And the idea of manufacturing meat is through tissue engineering technology, which I will talk about it in a bit. And the main purpose is to produce animal meat without using or hurting an actual animal. And the references will be on the last page. And requirements in the process of in vitro meat. So there's a few processes that goes into the production of it, and it's kind of like a hamburger where there's step-by-step process through the production of it. Okay. And first one will be cell source. So this is where they harvest the tissues from the actual animal. And the main thing is they use the cells called mysolite or myoblast, embryonic myoblast, is where located between the lamina and the sarcolamina, is where it is located in the skeleton tissue. And it uses high proliferative potential, is where the tissue has a lot of potential to expand and grow in size. And it's mostly from the skeletal muscles where the tissues have a more dense and more growth. Yeah. And this is the second process is called scaffold. So it is usually used from edible. It has to be an edible source from a non-animal sources. So where the myoblasts are attached onto the scaffold, and it is like a synthesizer to help it grow and expand. And usually they use Cytodex X, it is a microbarrier bead that has been used in scaffolds. That is the most common one. And the growth factors is, it requires a large bioreactors, and the nutritional components are available through the myoblast. So the main purpose is to provide the growth and expansion of the meat, because not only does the scaffold help it expand, but the growth factors is the main part where it grows in size. And the bioreactors is where the stem cells and skeletal muscle cells help culture the surface. Culture surface is where they put the tissue in a container or in a surface, and they help it mature and generate more cells. And it usually requires a large area for generation, a high number of muscle cells, and maintains low shear and uniform perfusion. So the fields used are electromagnetic, gravitational, and fluid flow. So how they do it is they put the tissue in a container that kind of has a vacuum seal that will expand, that will draw out the nutrition from the cells and help it multiply and expand. And this affects the differentiation and proliferation of myoblasts. So not every tissue or not every cell is exactly the same. So the process is slightly different. And the repetitive stretch and relaxation is about 10% of the cell's original size, and it's usually 6 times per hour. So this is the schematics or the methodology of the process of it is they have a live animal and they harvest the cells from its skeletal tissue, and they put it in they use growth serum to indulge it or to stimulate it. So the cells will attach to the scaffolds, and together it will help grow in a container, and then it can be used for other purposes. So this is a 3D printing. So I know what you think, like how is 3D printing affecting the process of the artificial meat? But it's one of the process that is used in the aftermath of after the meat is created. So its main part is a 3D CAD drawing is when you use a computer to upload a sketch or schematic in which the printer reads, and then use a fused deposition modeling, which is FDM, is where they inject the molten plastic or the powder injection to make a 2D base of layers of a mold that creates into a 3D image. And it's fused through adhesive and ultralight. Yeah. And the 3D printing is in this process is originally came from an organ transplantation technology, and it's another form of 3D printing. So how it works is like layers of biodegradable material, usually biodegradable paper, is removed through heating, and they will build layers of it into the meat to create the marbling effect to simulate a meat from an actual animal. So it looks more genuine and more real. And the conclusion is that it eliminates animal-related environmental impacts like greenhouse gas and CO2 releases. And it requires a lot of investment and research and development. So this is why the whole technology is not that common yet. And with the help of 3D technology, we can have better limitations and better mass production and large scale the production of it. And these are the references in MLA format. And thank you for listening.
Thank you, Paul. Interesting topic. So any questions, comments? Please, yeah.
Thanks for your presentation. I have one question to ask. Is the 3D printing is required high resolution, or the large error doesn't matter to the artificial meat? Is require high resolution or not?
Does the 3D printing require high resolution? I don't believe so, because it is not a traditional 3D printing, but more so it layers the meat, so it creates a marbling to stimulate a real meat. Yeah.
Thank you for your presentation. It was a good presentation, but I still have a question. It's about the cost. Do you have any numbers about, like, for example, what can cost a steak from a 3D printing? I mean,
you mean the cost?
Yeah. For example, what's the cost of like all the process, having a bioreactor and everything? Do you have any budget information or something?
No, but you can research on your own.
Thank you.
Yeah.
I have to thank for your presentation. It's creative. I have two questions. The first question is, could you tell us what is the raw material, the 3D printing usage, and how you stored it, and what is the basic ingredient about it?
Okay. So the 3D printing is like a normal inkjet printer, but the difference is it's built. The 3D layer is built out of a lot of mini 2D layers that uses an ink injection. So it uses a fused powderized material. It's similar to plastic, and they build it up into a 3D layer. Yeah. Does that answer your question?
So the material is protein? No, protein. Protein. The raw material is protein.
Protein?
Yeah, protein.
No. It's not protein. It's a powder-based material.
Oh, powder-based. Okay. Yeah. And the second question is, if I prefer the beef or the pork, can it timely adjust? Can timely adjust the test feeling between this kind of food, this kind of meat?
Mainly the topic I introduce is it's for beef because the technology it mainly focuses on beef, although there's other technologies that focus on chicken, lamb, or pork. But because the beef, it has the largest environmental impact pollution on globally. So this is why people are trying to solve the problem.
Okay, thank you.
Thank you for your presentation. I have one question. In the future, do you want to eat this meat instead of real meat?
Can you say that again?
In the future, do you want to eat this meat instead of real meat? Because most people against the genetically modified food.
That's a very good point. Personally, I like eating meat, but there's a lot of drawbacks. There's a lot of negative effects from the consumption of meat. So if the technology progresses, that may be a consideration.
Thank you.
Because like in the recent question, you said it isn't a protein. So what would you be eating actually?
No. Protein, not protein as in the 3D printer. I was answering his question, but
the powder, what is made of?
No, that's 3D printing.
So
wait, I thought he asked about 3D printing.
I mean, what will you be consuming? Like
you will be consuming the stem cells in where it's from the cow, and then they grow the cells. They grow the stem cell. So you'll be eating because in beef there's layers of fat mixed with layers of protein, and what you're eating from the stem cells it will be turned into ground beef. So it's mostly a mix of protein and fat already inside. Yeah, not like steak. It's ground beef.
Thank you.
Okay. I'm wondering if I want a special flavor in the meat, can I add it in it? Like I like the mango flavor mixed with the meat. Can we do that?
Yes, that's a good point because I didn't mention the flavoring that goes into the aftermath of the beef. It's a process between the finished product and where the meat is right off after the production of the lab is where they inject the flavoring into it to make it taste more like actual beef, because when you eat beef there's a flavor that is authentic to the beef, but because this is tissue grown, so the flavor is very subtle. and they inject it to make it more, to make it stand out more. So yes, you can do that.
So thank you, Paul.
Okay, thank you.
I think that's a very interesting topic. Okay, so the last presenter, Maxime. 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 Yeah. So yeah, you play. Yeah.
Okay. Okay, so I'm gonna present you my presentation. So the geographical information system for agriculture. So I'm gonna do. Can I use this? Maybe yes. Yes. Okay. So first, I'm gonna speak about. I'm gonna introduce the context, and then I'm gonna explain the GIS in principle, the use in agriculture and agronomy, and after I will deal with the limits and forward progress, and then the question, the conclusion, and the questions. So, what is GIS? So, usually we use software for this. So, GIS is used to stock, treat, analyze, and manage information. So, basically, we use a map. We use different layers on the map. I will explain it later to organize information and then reuse this information to apply on geographical space. So yeah, and so GIS helps to understand what belongs where. So. So GIS is actually used for almost everything. So retailer can use GIS to put pinpoints on the best location for new store depending on the customer needs. So I put an example here. Like for example, if you take 7-Eleven, they have like different 7-Eleven all around Taipei. And so if they put two 7-Eleven one next to the other one, they won't make good benefits. So GIS helps for this. It can be used for organization who take care about the species to protect the species. Police can use GIS too, and for sure there's an agricultural purpose. So it's the purpose I will explain today. So basically, GIS is made like this. First, you have the map. So you can add different layers on the map depending on what you're searching for. So you add your data. Previously, you collect data, and then you add it on the map. And so after you can analyze the different layers on the map with the data, and so it can show you what you really want to know. So it's a very interesting thing. So the impact on the agriculture. So I put two main examples. This is a screenshot from the one of the software we can use. So for the agricultural purpose, it can help to analyze the water input on the field, the impact on the crops, the soil mapping, and different type of inputs. So here, for example, we can see the crop yield map, and so you have the agricultural parcel mapping. So you can see where you have more yield, for example, and you can add another map about, for example, the water input, and so you can link the two results, and so you can analyze in the best way what's going wrong and what's going right, and so adapt your answer to the problems. So this is another example about GIS. So we can use to collect data. So we can use, for example, drones or satellites, or even other ways like to go on the field and to collect other samples and data. So yeah. So as I said, it helps to analyze previous crop yields, the terrain specifics, organic matter content, pH, moisture, and nutrient level on the soil, depending on the capability of the satellite or the drone. And so here finally it's another application. It's more about financial. It's to show you that we can use in a different purpose too. So here it's the map of United States, as you recognize, and so this is a map which shows the crop yield financial. So you can see that depending on the region of United States, the benefits per acre are different, and so depending on this, the state can take some measures or some decisions. So GIS helps to this too. So that's why it's a very interesting way to analyze data. And so yeah, it helps to visualize the needs and trends, and it results decisions and policy regulation in the markets. So the limits. Sometimes we can have very complex data, and so sometimes it can be impossible to analyze, or it can give incorrect. We can make incorrect generalization to the trends. So we need a lot of information. So more we have information, more we are accurate. So I put a little image to image what I mean. So yeah, more you have information, more your data and the accuracy of your data will be right. And so the layers can lead to some mistakes because sometimes some layers can be not adapt with other layers. When you mix two layers, some layers cannot cannot adapt to other layers. So yeah, sometimes you can make wrong decisions because you didn't analyze well the data. So it can be an issue. Oh, there's an issue. Okay. Yeah, so GIS can be even more useful in agriculture as farmers use it more. So it's something that farmers can use more and more. It's a very developing thing. So we encourage farmers to use it more. So the data are more accessible for everyone. So if the data are more accessible for everyone, more people will be able to use it, and the GIS method can develop even faster. And so yeah, the data if the data are more various and can provide more information, it can answer to the needs in a better way. And so the accuracy of data if the accuracy of data are checked, it can lead to better results too. So in conclusion, GIS revolutionize the way to process in every domain, especially in agriculture. And so yeah, it helps to answer some question, and like when the data is easily extracted, it can lead to better decisions and better distribution on inputs for crops, for example. Oh God. Yeah, and so despite the utility of GIS, it remains a costly thing because you have to buy the software or subscribe to it, and so yeah, not everyone can use it, but yeah, it can be very useful. Thank you.
Questions or comments? Yeah, please.
From page 6. Thanks for your presentation. Page 6. Could you know the highest value crops in this map? The information, the item of this, the item in this map. Which item is the most valuable?
The most valuable?
Yes, in this.
The blue color is that your question? About the color with?
Yes.
Yeah,
about the crop item.
The dark blue one. Yeah, because it's more. I know. Sorry. the dark blue one is the most valuable because you have 75 or more dollar per hour.
The item name, like the soy or the cotton or what, the plant in the map.
Soybean.
Oh, soy.
Soybeans.
Oh, soybean. Oh,
Yeah.
okay. Oh, thank you.
Sorry, it's more. Yeah. Sorry, I didn't mention it.
Okay, please.
Thank you for your presentation. And I have a question to ask. If a lot of farmers want to use the software and so they buy one and use together, is it illegal or?
I don't. It's not a problem of being illegal. I think the software is blocked to one computer or one like. I know I use it, for example, in my engineer school in France, and so the computer are registered for this software. So I don't know, maybe it's not the case for every software, but with the one I used, it was one computer for one software, and so the software know the IP address of the computer, so you can use it just for this computer. So they cannot, unless every farmer goes in one house and they all use the same computer, but yeah, I don't think it's illegal. I think that it's more depend of the way the companies can protect the access of this software.
Yeah, and the data. Yeah, please, Paul.
I like the presentation a lot. And is GIS system better than the other systems out there?
Sorry?
Is the GIS system better than other systems out there? And if so, can you explain in like one sentence why it is better?
I think GIS, you can use GIS and other methods in the same time. I don't know if I will answer to your question, but GIS is one of the methods to proceed in a better way to analyze your crops and what you have to do. But I think at the same time it cannot like. It's not because you use GIS that you won't use something else to analyze your crops. And I think it's a very good tool to analyze everything, but it's not like if you have other methods to process. I think it's even better because you can compare your results with GIS results. So I think you can. Yeah, it's one of the tools you can use, but I don't think there's some better tools from other or something. I just think it's a very good tool, and you can use other to be more accurate too. I answered to your question.
Yes,
yeah?
yes, thank you.
Thank you.
It's a good presentation. Thanks. And I have a little question. Do you think it's possible to combine the GIS system and the GPS system? And is there anything good if we combine these two technologies together? Thanks.
So GPS system, you can use actually a GPS data to put in GIS. Let's say that GIS is database for everything you want to put in it. And so if you have GPS data, you can add to your GIS. And so you will have a different, and you add your GPS layer to your map. And so you will have your GPS information. So you can mix it all. I mean, that is very convenient with GIS. It's because you can use whatever you want and all the data you want. So it's designed by your own. So yeah, you can still use GPS in GIS.
Yijing, do you have any questions about the slide? This is I suggest you to prepare your slides. Look at the maps. You put some keywords in additional to the map, but also have the keywords, so the audience is easier to follow the key points you want to present. Any more questions or comments from Professor Chen?
This one, previous one?
Yeah.
Another one?
The mapping different layers.
Oh, yeah, this one. Yeah.
This mapping is very important. You can put many inputs here. So somebody question is a GPS, and GPS is not equivalent to or comparable to GIS. GPS is something you can identify your location, your